In this video, you will learn how to solve for the value of x in this nice Olympiad exponential equation. We are asked to solve for x. Don't forget to give this video a thumbs up, subscribe to my channel for more simplified mathematics solution content. Now to solve this, I want you to note that 15 in this expression can be equal to 3 multiplied by 5, right? Great. So that means I can simply replace 15 by 3 multiplied by 5. So if I do that, that expression will automatically give me 3 to the power of x multiplied by 5 to the power of x squared, right? And this will be equal to 3 multiplied by 5. Great. Now, having done this, what I would think of doing next is to divide both sides by 3 to the power of x multiplied by 5. Now, why am I doing that? Just watch and see what it will turn out to become. So if I divide this side and divide this side by 3 to the power of x multiplied by 5, and I divide here by 3 to the power of x multiplied by 5, what will the result be? If you notice here, you notice that 3 to the power of 3 will clear 3 to the power of 3 and 5 will clear 5. So I will be left with 5 to the power of x to the power of 2 divided by 5, and this will be equal to 3 divided by 3 to the power of x. Great. Now, do you notice something in this expression? That we have the denominator and the numerator all having the same base. If we put this to the power of 1 and put this to the power of 1, I've not changed anything. Now I want you to draw your mind to a law of indices. In that law of indices, if you have a to the power of x divided by a to the power of y, because they have same base, this is the division law of indices. This will give us x, a to the power of x plus what? Plus y. So if we apply that to that expression, that value will give us 5, right, to the power of x squared minus 1, right? And this will be equal to 3 to the power of 1 minus what? Minus x. That is the point at which we will get to. Now, if you look at this expression very well, you will come to see that the two bases are not same. And this makes this solving of this question very, very difficult. The only way out is for us to apply the laws of logarithm. It's either we use the law of logarithm or we use the natural laws of logarithm. In this aspect, our advice we use the law of logarithm. So we take the log of both sides. We have the log of 5 x squared minus 1 to base 5 equal to the log of 1 minus x to base what? To base 3. Now, having done this, we will use the common laws of logarithm, which shows that the powers will always multiply the whole logarithm. So if we do that, we'll have x squared minus 1, right, multiplied by the log of 5 equal to 1 minus x multiplied by the log of what? Of 3. Now, in order to find the value of x, we're going to divide both sides by what? We'll divide both sides by the log of 5. If we divide both sides by the log of 5, we're going to have that expression to now give us. From here, you see that the log of 5 will clear the log of 5, and then that whole expression will now give us, on the left hand side, we'll be left with x squared minus 1 squared, right? I've not changed anything, and that will be equal to 1 minus x, right, log of what? 3 divided by log of what? 5. So I didn't change anything because 1 square is still the same thing as what? 1. So this expression will now make us recall a law of logarithm. Now if I have the log of a divided by the log of b, remember if there is no logarithm base assigned to them, that definitely tells us that they are both in base 10. So since they are both in base 10, this will give us the log of a to base what? To base 5. So if we apply that over there, we'll have that logarithm expression to now give us x squared minus 1 square, right, equal to 1 minus x multiplied by the log of 3 base what? Base 5. Great. Now what we are going to do in order to find the value of x, since we have expressions involving x in the left and the right hand side, is to subtract both sides by 1 minus x multiplied by the log of 3 base 5. So if we do that, we'll have this expression to become x squared minus 1 square, right? And this will be minus 1 minus x, right, multiplied by the log of 3 base 5, and this will be equal to 0. So if you look at this expression very well, you'll find out that we can expand this, and that will give us x squared minus 1 square, right? And this will give us minus 1 plus x, and this will be multiplied by the log of 3 base what? Base 5, and this will be equal to 0. Now, having done that, we are going to simplify. Now, if we simplify, I want you to note that this expression can still give us x squared minus 1 square multiplied by minus x or plus x minus 1, right? Log of 3 base 5, and this will be equal to 0. I didn't change anything, I only inverted this, and if you simplify this, you still get that expression. Now, having done this, let's recall the law of logarithm of indices or algebraic formula that if we have a square minus b square, this is the law of difference of two square. This will become a minus b, right, multiplied by a plus b. Now, if we have that, this whole expression will now give us x minus 1, right, multiplied by x plus 1, right, and this will be plus x minus 1 multiplied by the log of 3 base 5, and this will be equal to 0. So what do we have here? You can see that we have x minus 1 as a common expression, as a common part of that expression. So we are going to simplify by bringing the common term out. If we divide all these by x minus 1, we'll be left with x plus 1, right? And this will be plus. If we divide all these by x minus 1, we'll be left with what? Plus log of 3 base 5, and all these will be equal to 0. So from this expression, which represents the zero product rule, you'll come to see that we'll have the first case x minus 1 to be equal to 0, and our second case we'll have a second case to be x plus 1 plus log of 3 base 5 to be equal to 0. Now from this part, you can see that if we add 1 to both sides, x will be equal to 1, which is the solution to that algebraic expression. Now, having gotten one of the solution, we're going to look forward to looking for the second solution. From this expression, we can get the second solution. If we take all values without x to the right hand side, this will be equal to minus 1 minus the log of 3 base what? Base 5. Now, if we do that, you're going to find out that the value of x can be equal to minus 1 multiplied by, because 1 is common, 1 plus log of 3 base 5. All this is common. If you simplify this whole expression, you find out that you're going to get the other expression. So that is the value of x. But we can still simplify it further. I want you to recall the law of logarithm, that the log of a base a is equal to 1. So if we do that, that simply tells us that if we have the log of 5 base 5, it can be represented or replaced with what? 1. So that expression will now make our x to be equal to negative 1 multiplied by the log of 5 base 5 plus log of 3 base 5. Now, why have we done this? Is so as to simplify that expression easily. Now, recall that according to the law of logarithm, if you have the log of x base a plus log of y base a, because they have same base, this can simply give us the log of x y base what? A. That is the product law of what? Of logarithm. Now, if we do that, you're going to find out that this value will give us x to be equal to negative 1 multiplied by the log of 5 times 3 base what? Base 5. So what would that expression give us? That will now give us the value of x to be equal to negative what? Log of 15 base what? Base 5. So this is another solution to that that expression that is given to us. So the two solutions we have for that expression, we have x to be equal to 1, and we'll have x to be equal to negative log of 15 base what? Base 5. These are the two solutions that satisfies that exponential equation that is given to us up here. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.